This is problem 108 of Neetcode on 50 word break. So in this problem, we're given a string and a dictionary of strings, and we're gonna have to return true if with the strings within this word dict, we can compose the string as that we're given. So for example, here, if we take a look at the strings we are given, so we're given neat and code, and we have to compose the word neat code. So can we use these words to create neat code? Well, obviously yes. And if we take a look at this second example, we have the word apple, pen, apple, and we have the word um, apple, pen, and eight. So our first question that is important to answer is: can we use a word in the word dict more than once? Yes. So you can use apple twice, and then you can use pen. So um, let's take a look at the time and space complexity. So we're gonna have to do something that is as good as or better than big of n times t. So n is gonna be the length of the string, m is gonna be the number of words, and t is gonna be the maximum length of any word inside the word dict. So to solve this problem, we're gonna have to use dynamic programming, and let's take a look at how we are gonna solve this. So what I will do is that I will create an index for each single characters inside the string we are given, and I will make sure that this new array that we're creating has an additional index at the end, and I will set this additional index to be true, and all the other indexes referring to a character inside our string New York will be set to false. So what I will do is that I will start at the um, the very last index here, and I will decrement like that. And I will go for every single words inside my word dict, which is here. And I will take a look if that word is basically the same of the one that we have at that particular index. So let's say that we are starting at k. So basically our word is only k for now. So is there basically a k inside the word dict? No. So we're just gonna keep going, and we're gonna add k. We're gonna add r. And now, do we have an rk inside the word dict? No. Do you have an rk inside our dict? No. But do we have York inside the word dict? And yes, we do. So what I will do is that I will set its index value to be equal to the value at the index that is basically to the right of the entire word. So that value is going to be basically here, right? So I'm just going to take the length of the word plus 1, and I want to take that index value. Now it is true. So I can write true. And you're going to see why after we are doing this. All right. So once that this is done, we're just going to loop again, and we're going to go see W. But actually, once we set it equal to once we set a word equal to true, we actually want to break this loop and just start again from scratch with another index to the left. So we're gonna start with W, and we're gonna see if the W letter itself is in the word dict. It is not, so we're gonna keep going. We're gonna see E. Is EW inside the dict? No. But is new inside the word dict? Yes. So what we are gonna do, we're gonna take that word, so the new word, and we are gonna set this equal basically to the value at the index that is one more than the length of its words. So we have new, or we're going to do new plus 1. So it's going to have, so we're going to take basically the value at the index of y, which is true. And we're going to set that f here to be equal to true. All right. And now let's see why we are always taking the index that is 1 to the right of the length of the words. You'll see it makes a lot of sense. So what if instead of York, we just had your like this. So we no longer have a K. So let's just start again. And we're gonna set a false to the Y and N. And we're also going to set an additional index after the end of the string given, and we're going to set that index to be the value true. So let's take a look at what's going to happen um, if let's say we are at our W, and we go to our E, and then we go to our N, and now we see, oh, okay, new itself is inside, well, it is inside our new dict, right? It's inside our word dict, sorry. So what we're doing is that we're just going to set that index to be the value of the Y here, because we know that if the Y is a true, is a T, it means that all the other words before that can be completed inside the word dict. So by this way, we start from the end, and we see if we can complete that, so that even if we had another word like, for example, this, right? Say we have this here. By simply looking at the index that is right to it, we know that if it is false, it means that somewhere along well, the rest of the string, we can complete it with the words inside our word sticks. So if it is true, it means that the rest of the sentence can be completed. So I hope you get the logic. And with that being said, we can jump into the code. So first, what I'm going to do is that I will create basically a value false. And I want to have this basically for the len of the s plus 1, because we are adding an extra index. And that extra index that is going to be at the index of the len of s, that it is going to be equal to true initially. So this is the initial setup. And then I will have my reverse for loop. So I will say for I in the range of len plus s. And I want to go up to index 0. So the bounding index is going to be -1. And I'm going to set it the last value to be -1 because we are using a reverse for loop. And I will go at, well, for each index, I'll go for every single words inside the word dict. So for W in word dict, right? I want to first check if the current index we're at plus the len of s, or the len of W, right? So if the current index we are at plus the len is greater than the current len of the string, it must mean that we have something like, if I go back to my example, and I just clean this up a little bit. So let's say we are at, let me also add a k, because otherwise the example makes no sense. So let me add a k. So let's say we have ork. Well, we're going to be at the index. We're going to be at the index 4, right? So at the index 4 here, plus the length of the word, which is, let's say York. We have York here. So we're going to have basically a length of 8, but the length of the entire string is 7. So this means that we actually can't put that word at this particular place, because we're looking for a 3-letter words, and York here has 4 letters. So this is the logic that we're using here. So if basically the index plus the length of the word is, well, it has to be smaller or equal to the len of s, so that we can do any further actions on it. And lastly, is that word exactly the same as the substring we have? So we're going to do this by saying that we want to check that particular string, starting at the index I we are at, up to I plus the len of s. So is this really the same as the word w? Okay, and if both are true, we can set basically the index I inside the DP that we created to be equal to basically the index to the right of that word, which is going to be basically I plus len of w. And after this, if this is equal to true, so if dp, um, so if dp I, meaning that if this is true, we can break. All right. So now if the very first entries inside our DP is set as true, it means that the rest of the string can be completed with the words inside or ticked. So by returning DP at the index 0, we are going to have this answer right away to us. We get a wrong answer. So let's see why here. So we are starting from, we need to be starting from the first index. The first index is basically, well, the end of the string, right? Because we're starting from the really end. So I need to subtract 1 to the len inside my for loop because I need to be starting from basically the last index. So let's get another error. So let's see why. So we're creating our basically a false value for all the characters, and we're setting the entries that we created for the purpose of having an additional space to be equal to true. And now we're going for basically a reverse first loop. We're going to go for every single word inside of our dict. And we want to check if the I plus the len of w, right on, if this is, it has to be smaller or equal to the len of s. And that substring here that we have at that particular index to the end, it has to be equal to the word. But yeah, the error was quite obvious here because I want to take basically the index plus the len of the word, right? Because this is how we'll check the basically the entire words that comes after this this particular index. By saying w, I will check for the index plus the entire len of the substring that we're given. So let's test this again, and now it works. Awesome. Great. So also in terms of time and space complexity, well, for the space complexity, well, the len of the string is basically the len of our DP here, right? So if the len of the string is equal to n, or space complexity will be big O of n. For the time complexity, we are going to go for every single character. So there's definitely a big O of n inside, but there is more than that. We're also going through every word. So if every word is basically m, we are at a time complexity of big O of n times m. And also, we are also checking if every single word is inside the, well, is a substring of the string s. So this has also a time complexity of, let's say, t. So this is how we get a time complexity of big O of n times t, which is exactly what they recommend us to have in a problem. So with that being said, I hope you enjoyed the video. I hope you learned, and I also hope I'll see you in the next one.